listening. We're going to go just to this table down here. So you know that the amplitude of a cosine and a sine graph was what? It was half the vertical distance. So what was it? 1. The amplitude was 1. Correct? Let's talk about transformations now. Listening? If the amplitude is 1, that means it was from -1 to 1. Correct? It was an amplitude of 1. What's the only thing that's going to change my amplitude? Let's talk about transformation options. Okay? If I vertically translate it up or down, does that change my amplitude? No, because it's still the same difference in height. Correct? Same distance from min to max. Like if I went from 0 to 2, it's still a distance of 2, so my amplitude is still a half. Okay? Vertical translation doesn't change it. What about horizontal translations? Would that change my amplitude? No. Okay. What about horizontal stretches? Horizontal stretches would make it go from here to here, but it would still be the same height. Correct? Or from here to here, but it would still be the same height. So would that change my amplitude? No. What about a reflection in the x? I just reflected it in the x. I don't have a third arm. I visualized it. Would it change it? Okay, what about a reflection in the y?
No.
No. But the only thing that's going to change this bad boy, amplitude. Okay, let's talk about it. So if my amplitude is 1, and I vertically stretch it by 3, it's now going to be? 3, thank you. That was way faster than period 1. They just hummed for a while. Because it's 1 times 3, correct? Okay, what if I have a vertical stretch by a factor of 20? What's my new amplitude going to be? 20, because it's 1 times 20. Ah, so smart. What if my vertical stretch is a half? What's my amplitude going to be? A half, correct? So what could we say then? The vertical stretch equals the? Yes. So true. Need a vertical. Oh, need a pen. Vertical stretch equals the amplitude. Okay. Your equations are always in this form. That's where you get your A, your B, your C, and your D for transformations, correct? If you forget what that form looks like, on the very bottom of the right-hand side of your formula sheet, it's there. Okay? No paper throwing. We are not poor. Okay. So, equation, yes? A, B, C, D. So, does this one have a vertical stretch? Who's so into the, no. Yeah, it does. We have an A, we have sine or cos, then we have our B. The B is found between the sine and the x. C is in the bracket, C is at the back. A is your vertical stretch. Does this have a vertical stretch? Let's try again. Yes. Okay, it has a vertical stretch. By a factor of what? 2. Y's never change. That's why they're awesome, remember? Vertical stretch by a factor of 2 about the opposite axis. So it's about the x-axis. So if I have a vertical stretch by a factor of 2, what is my amplitude? 2. We're not going to do that third column for now. Okay. I don't know why it goes 1, 4, 5, but it does. Okay. 4. Does it have a vertical stretch? No. What is my A value? 1. What is my amplitude? 1. What if that was a -1? What would my amplitude be? 1. The negative doesn't do it. It's a reflection thing. It didn't do anything, correct? Okay. What's my vertical stretch here? 1, which means there really isn't one. What's my amplitude? 1. Okay, let's talk about the period of the graph now. Yesterday we found the cos graph and the sine graph. The period is how long it takes to repeat itself, correct? In degrees, what is the period of a sine and cos graph? 360 degrees, because that's how long it takes to go around the unit circle, and that's how we draw one period of the graph, is using the unit circle, yes? Yeah. So sine and cos graphs repeat themselves every 360 degrees, or what radians?
2 pi.
2 pi radians. What's the only thing that's going to make it repeat faster or slower? Let's talk about this. Moving it up or down, does that make it repeat faster or slower? Because now we're looking at this, the horizontal distance, not the vertical anymore, correct? Okay. What about moving it left and right? Is that going to change the period? No? Okay. What about reflecting it? Visualize it reflecting in the X, reflecting in the Y? No? Okay, what about a vertical stretch? It just got taller. Okay, what's the only thing that's going to affect this? Horizontal stretch. And by Y, he means the Y with an extra tail. The X. Yes. The X totally stretches it. Because it's an X value that's stretching. So it's a horizontal stretch. So if I take, let's do degrees. I have 360 degrees, right? And I horizontally stretch it by a factor of 2. What's it now going to be? The period is 360 degrees. I horizontally stretch it by a factor of 2. What's it now going to be? 720, which has a 2 in it. Not a 4, but 4 divided by 2 is a 2, gets the middle, and then 7, 2, and then there's a 0, and you get 720. That's where you're going with that, with your 4 answer. Okay, now, what if I horizontally stretch it by a half? 180. 180. What would that be in radians?
Pi.
Pi, because it would be 2 pi divided by 2, right? Just multiply by half. Okay, so it's the horizontal stretch that helps us get, listening, the amplitude is equal to the vertical stretch. That's true because the amplitude is 1 to begin with, yes? Your horizontal stretch is not equal to the period. The period is 360 or 2 pi. You have to take that horizontal stretch and stretch 360 or 2 pi correctly. So, we're going from equation to words. What happens with your x's? Your x's be crazy, so they're going to flip. This one has a 1. My b falls between the cos and the x or the sine and the x, okay? This one has no horizontal stretch, right? My b value is 1. So what is the period of this graph going to be? If it didn't change? 360 degrees or 2 pi in radians. Okay, this one, does it have a horizontal stretch? Is there a number between sine and x? Yeah, it's a 3. So we have a horizontal stretch. By a factor of what? 1/3, because we're going from equation to words, and x is be crazy. About the y-axis. So, we're taking 360 degrees and multiplying it by what? 1/3. And so we get 120 degrees. Or we take 2 pi and we multiply it by 1/3. And we get 2 pi over 3. You do the third one, which is numbered 5. I don't know. This is a horizontal stretch by a factor of 2 about the y-axis. So we're multiplying by 2 now, so we get 360 degrees times 2, 720 degrees, or 2 pi what? Times 2 equals 4. Okay, below it says, the period of y equals sine theta is what? The basic sine theta, what is it? 360 degrees or 2 pi. The period of cos is 360 degrees or 2 pi. Here it says the parameter b in the equation y equals fb of x, where f of x is sine x or cos x, results in a horizontal stretch by a factor of what? Nope. By a factor of what? Not b. 1. Yeah. Over b. About the. Hey guys, seriously? Zip it. So this means B gives the number of cycles in 360 for sine and cos. The other thing you can do is you can multiply by the horizontal stretch, or you can divide by the B value in the equation. Because if, say the B value is, say I give you this, y equals cos 3x. If I divide by the B, this is the B, I can divide by the B, so I can go 360 divided by 3, and I would get 120. Why can I just divide by the B? It's the same as multiplying by 1 over B. So you can either multiply by the horizontal stretch, or you can divide by the B value. You guys get it mixed up and put like 2 together, and you divide by the horizontal stretch. That does all the things. So you can either remember that you just take your original period and you multiply by the horizontal stretch, or you can remember that you take your original period and you divide by the B value from the equation. Like you don't flip it, you don't change it. You just keep what it is. Both work. What does not work is putting the 2 together and dividing by the horizontal stretch. That is bad. Okay? So you divide by the B value that you directly take out of the equation, or you multiply by the horizontal stretch, which is the flipped 1 over B. Okay, you're going to flip over.
I'm still ready.
Go. So the amplitude of the first one is 3. It has a horizontal stretch by a factor of what? Yep. About the y-axis. And the period is 360 times what? 1/2, which is 180, or 2 pi times 1/2, which is pi. So if you multiply by the horizontal stretch. If you divide, you would divide by 2, by the B value. Okay, this one has an amplitude of 2, and then it's a horizontal stretch by a factor of what? About the y-axis. Okay. We go 360 times a third is what? 120 degrees. And then 2 pi times a third is 2 pi over 3. This one has an amplitude of what? 3. Amplitude is always what? What did we talk about that yesterday? Positive. So here we have a horizontal stretch by a factor of what? Of 2. About the what? Y-axis. 360 times 2 is what? 720. I'm going to send a podcast to the table's parents. 2 pi times 2 equals 4 pi. I'm like, you know that noise that's incessantly in the back the entire time I'm teaching? That is your children.
Hey, you guys are really loud, like, in the podcast. Like, when I was watching them, like...
Oh, yeah.
Like, it's every other...
Full fun fact. Even if you're whispering, this is a conference mic. It picks you up better than it picks me up. So... So funny. Ha 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 ha. Okay. Horizontal stretch. I'm going to start chewing my gum aggressively loud so they should listen to that. Because my annoyance level is increasing. Factor of 4 about the y-axis. So 360 times 4 Guys, I wasn't joking. 2 pi times 4. 8 pi. Okay, here we have to state the period and amplitude. The period for this one is 360 degrees times what? Times 1/3, which is 120. Or 2 pi times 1/3, which is 2 pi over 3. And the amplitude equals 2. This one, the period, equals 360 degrees times 2, which is 720 degrees, or 2 pi times 2, which is 4 pi. And then the amplitude equals, example 3, describe the transformations of words and create mapping functions below, state domain and range. Okay, so the mapping is going to be x, y becomes, equation of mapping, x is be crazy, so we're going to get 1/3 x, comma 2y, which means we have a horizontal stretch by a factor of 1/3 about the y-axis. And then a vertical stretch by a factor of 2 about the x-axis. All right. Domain and range. Domain of every function unless it's restricted is what? Of every x sinusoidal function is what? X such that x is an element of the reals, or it goes on for life. Because every sinusoidal function, and just so you know, sinusoidal functions are ones that repeat themselves. So it's called a sinusoidal function, and then specifically a sine and a cos are sinusoidal functions. Yeah?
What was the attendance question today?
Didn't have one.
Why?
Didn't deserve one.
Can we do it now?
Nope. Range. Y such that. Okay. Did this graph move up or down at all?
No.
No, so it's symmetrical about the x-axis. That means it's the same amount up as it is the same amount down, correct? Normally a sine or cos graph is 1 up and 1 down, correct? This one's vertically stretched by what? 2. So now instead of it being 1 up, it's going to be 2 up and 2 down. So it's going to be -2 is less than or equal to y, is less than or equal to 2. Y is an element of the reals in interval notation. -2 to 2.